Welcome back to Java Internals Crashcasts. I'm your host Sheila, and today we're continuing our journey through the fascinating world of concurrent collections. We're in the final section of our chapter on concurrent list implementations, and we'll be diving into ConcurrentLinkedDeque. Victor, are you ready to unravel this double-ended mystery?
Absolutely, Sheila. I'm excited to explore this powerful concurrent data structure with our listeners. Before we begin, let's remind everyone that to get the most out of this episode, you should be familiar with basic concurrent collection concepts and have a good understanding of queues.
Great point, Victor. Now, let's kick things off with a quiz question for our listeners. Here it goes. In a multi-threaded environment, what potential issue might arise when using a regular linked list as a double-ended queue instead of a concurrent LinkedDeque?
Ooh, that's an intriguing question, Sheila. It really gets to the heart of why we need concurrent collections in the first place. I think our listeners will need to consider the nature of double-ended queues and the challenges of multi-threaded access. But let's not give away too much. We'll reveal the answer at the end of the episode.
Agreed, Victor. Let's start by breaking down what we mean by a deque. Can you explain this term for our listeners?
Certainly. A deque, short for double-ended queue, is a data structure that allows elements to be added or removed from either end. Think of it like a two-way conveyor belt in a factory. Items can be placed on or taken off from both ends. In Java, we have the deque interface, which extends queue, adding methods for operations at both ends.
That's a helpful analogy, Victor. So, how does ConcurrentLinkedDeque fit into this picture? What makes it special?
Great question, Sheila. ConcurrentLinkedDeque is a concurrent implementation of the deque interface. What makes it special is that it's designed for use in multi-threaded environments. It provides thread-safe operations without using locks, making it a non-blocking data structure.
Non-blocking? That sounds interesting. Can you elaborate on what that means and why it's important?
Of course, in a non-blocking data structure, we prevent thread interference without using locks. Instead, it uses atomic operations and clever algorithms to ensure that multiple threads can safely access and modify the deque at the same time. This approach generally offers better scalability and reduces the risk of deadlocks compared to lock-based alternatives.
I see. So, if I understand correctly, ConcurrentLinkedDeque allows multiple threads to add or remove elements from either end simultaneously without causing data corruption or inconsistencies. Is that right?
Exactly, Sheila. You've got it. This makes ConcurrentLinkedDeque particularly useful in scenarios where you need high concurrency and low latency, such as in producer-consumer patterns, where multiple producers and consumers might be working with the deque at the same time.
That's fascinating, Victor. Now, I'm curious about how ConcurrentLinkedDeque compares to its single-ended counterpart, ConcurrentLinkedQueue. What are the key differences?
Great question. The main difference is, of course, that ConcurrentLinkedDeque supports operations at both ends, while ConcurrentLinkedQueue only supports operations at one end. This makes ConcurrentLinkedDeque more versatile. However, this versatility comes with a slight performance cost. If you only need queue operations, where the first item in is the first item out, ConcurrentLinkedQueue might be a better choice.
I see. So it's a trade-off between flexibility and performance. Speaking of performance, how does ConcurrentLinkedDeque perform in general?
ConcurrentLinkedDeque is designed to be fast for basic operations, like adding, removing, and peeking at both ends. However, it's worth noting that when many threads are accessing it at the same time, performance can slow down a bit. The non-blocking algorithm uses a helping mechanism, where threads may end up doing extra work to help complete operations started by other threads.
Interesting. It sounds like there's a lot going on under the hood. Are there any common pitfalls or misunderstandings developers should be aware of when using ConcurrentLinkedDeque?
Absolutely, Sheila. One common misunderstanding is about the consistency of the size method. In a concurrent environment, the size of the deque can change at any time, so the result of size might be inaccurate by the time it returns. It's generally not a good idea to rely on size for decision-making in concurrent code.
That's a great point, Victor. It reminds me of Heisenberg's uncertainty principle. the act of measuring can affect the system. Now, could you share some best practices or tips for using ConcurrentLinkedDeque effectively?
Certainly. Here are a few key tips. First, use the offer and poll methods instead of add and remove when possible, as they don't throw exceptions. Second, be cautious with methods that operate on the first or last element in concurrent scenarios. Third, if you need a snapshot of the deque's contents, use toArray. But be aware it creates a new array each time. Lastly, remember that iterators are weakly consistent, meaning they may not reflect all changes made after the iterator was created.
Those are really helpful tips, Victor. Now, as we're wrapping up, could you share an interesting fact or anecdote about ConcurrentLinkedDeque?
Sure thing, Sheila. Here's an interesting tidbit. ConcurrentLinkedDeque was introduced in Java 7, and its implementation was inspired by work done by Moyer, Shavit, and Herlihy on concurrent deques. Their algorithm, published in 2003, was a significant advancement in lock-free data structures.
That's fascinating, Victor. It's always interesting to see how academic research translates into practical tools for developers. Now, let's circle back to our quiz question. Can you reveal the answer?
Absolutely. The potential issue when using a regular linked list as a double-ended queue in a multi-threaded environment instead of a concurrent linked deque is data races. Multiple threads could be modifying the list at the same time, leading to lost updates, inconsistent state, or even corrupted data structures. ConcurrentLinkedDeque prevents these issues through its non-blocking, thread-safe implementation.
Thank you, Victor. That wraps up our discussion on ConcurrentLinkedDeque and our chapter on concurrent list implementations. In our next episode, we'll be starting a new chapter on advanced topics, beginning with the fork-join framework. Don't miss it.
It's been a pleasure discussing ConcurrentLinkedDeque, Sheila. I'm looking forward to diving into the fork-join framework.
Thanks for tuning in, listeners. If you've enjoyed this episode, please subscribe to Java Internals Crashcasts and leave us a rating. Your support helps us continue bringing you in-depth explorations of Java's internals. Until next time, happy coding.